Hello everybody, and welcome to today's presentation, Database Metrics That Matter, brought to you by Influxdata. I would like to introduce you to our presenter, Katy Farmer. Katy lives in Oakland, California with her husband and 2 dogs. She loves to experiment with code, break stuff, and then try and fix it. She learned code at the Turing School of Software and Design in Denver, Colorado, and it gave her the perfect chance to break stuff before she knew how to fix it. You can ask her about Ruby, OOP, Go, natural language processing, Russian literature, Star Wars, Dragon Age, or chord progressions.
Today, we are going to be talking about database metrics that matter. And I talk about databases quite a bit, mostly for fun, and a lot of times people just leave while I'm talking. So I'm really glad that you all are here to listen and learn and hopefully ask questions that help us all understand things better. So first of all, hi, I'm Katy. I am a developer advocate at Influxdata. Essentially, my job is to listen to our community, learn, and help people with technical problems. Sometimes that means understanding how a database works and helping optimize queries, and sometimes that means just understanding why someone might want to use a certain kind of database or a different type of monitoring tool. You'll see my Twitter handle on every slide and my email address here. Feel free to contact me. I'd love to talk to people, and I want to answer questions and start conversations. So I'm always happy to hear from you. Now, at this point, you're probably wondering what Influxdata knows about database metrics. Why am I the person to explain this to you? Well, first of all, we make an open source database, InfluxDB. Maybe you've heard of it. It's a time series database. It's probably about 6 years old. It's really well adopted, and it's the kind of heart of our open source platform for time series data. And sometimes when I hear that phrase, I think that I don't know what that means. So what it means is that anytime you have data where you care about the timestamp very much, we can help you collect the data, take action, analyze the data. That means, how do we store it? We store it in InfluxDB. How do you get alerts on it? How do you build dashboards? Those are all things that we do, and we do them all with open source products. We have over 180,000 unique and active installs of InfluxDB in the world at the moment, and people use us for just about everything. I have talked to really big, well-known gaming companies who use us to make sure that players worldwide keep connected, and all the way down to researchers who are using tiny sensors to monitor whale migration patterns and map out whale songs. So we kind of are a tool that allows people to get the data that matters to them, whether that's who's on your leaderboard or how your whale pod is doing. Well, that's up to you. We're going to talk about a few things today. First, why do we monitor our databases? And then once we're monitoring, which metrics are important to us? And then, of course, how are those metrics meaningful, or how do we make them meaningful? And then we have like a little party where we pat ourselves on the back and say, great job, you learned a lot today. Let's go ahead and get started. So one of the first reasons that we monitor our databases is so that we know when outages happen. Because the last thing you want is to come into work and find out that your database has been out all weekend, right? So knowing and detecting those outages is an important part of why we need to monitor our databases. We also want to minimize downtime. these are two sides of the same coin. Not only do we want to know when our database is out, but if it is out, how do we make sure that it is down for the least amount of time as possible? You can also use database monitoring for things like predictive analysis. So if you have all the metrics available, you can make good predictions about, say, what storage requirements you are going to need in the next month or year. Because running out of storage on your database is not anyone's idea of a fun problem to have. So being able to use the metrics that you have collected in order to increase future efficiency and performance, that's one way that we can get a lot of value from monitoring our database. It also makes debugging our database problems a lot easier. If you already have metrics in place, when problems occur, you can use those to trace evidence back to what caused the problem. Now, they won't always lead you to a root cause, but they will show you a lot of symptoms that ripple through the database as this problem occurs. So if you know that your database crashes every time a particular query happens, you can use the metrics that you're already gathering to find out, well, maybe it's retrieving too many records, or maybe it's like locked on concurrency, and maybe it's not related at all, right? But these kinds of like correlation that you can find in the metrics makes the debugging process a lot faster. And then databases are a really good indicator of system health. When things are going wrong in the database, that can often signal that there's odd behavior elsewhere in your application. So an unhealthy database can tell you a lot about your system. And a healthy database can also help you keep track of the rest of your application. If your database is healthy, it's much easier to see what's going on in your application. Now, there's one problem with monitoring our database, and that is that databases collect everything. I don't know if you've ever tried to look up, say, MySQL metrics, but there are hundreds of them. And it's not easy to know which of them matter. And maybe you say, well, when in doubt, monitor everything, right? But for me, I'm always aiming for the least amount of overhead. I don't like using tools that are too big for the problem I have. So in order to kind of adapt to that modular idea, I really just want to measure what I think is important to me, and then I can always add on metrics. Or alternately, you can measure everything if you have the resources to do so, but only build dashboards for the metrics that matter. Every database is collecting metrics all the time. And that means that not only are there hundreds of different metrics, but there are millions of entries in those metrics individually. So our job is to parse which of those metrics is most important and what effects they have on our system. The first metric that I care about is throughput, which is very basically how much is the database doing. When you think about it, this is the most traditional measure of traffic. We often start with saying, well, how many queries per second are there? Or how many transactions per second? We measure this differently depending on what kind of database it is. So in a relational database, maybe I care more about transactions per second. In a time series database like InfluxDB, I might care more about points per second or bytes per second. All of these things are recorded, but they their relevance changes depending on what you need from your database. But there's still a problem here, which is that because this is the most traditional method of measuring how busy your database is, it's also fairly one-dimensional, because databases are meant to be busy. They're active, they can handle really high loads. So sometimes just knowing the queries per second, well, it doesn't give me a lot of context. If anything, it's too scoped in. So what we end up doing is adding more metrics that give us a more complete picture. So the second thing that I care about is execution time, which is how long does it take the database to do its job? This also is a relatively traditional way to measure the database. But when you think about it, one of the things you care about is, let's say that you navigate to my very cool blog website because you love reading my blog. You want to know all my thoughts about databases and Star Wars and whatever else is on the brain. If you go to that page and look up a blog from 2 years ago, and you have to wait more than, I don't know, say 20 seconds, what are the chances that you stay on that web page? They're not good, right? As we become more sophisticated, we wait shorter and shorter amounts of time for things to load and be successful. So on the database's end, what that means is that from the time it receives the request all the way to when it can deliver a successful response, that all goes into execution time. That includes the latency, which means how long does it have to wait in a queue before it even starts running in the database, plus the time it actually takes to complete the task. And there's some more context here that is helpful, which is that slow is relative to your database. Again, if I'm using MySQL, and I'm not trying to pick on MySQL. MySQL is a great database that a lot of people use. It's just good for comparison points. If you're using MySQL, there's a global variable set in the performance database that's called slow query, which you can use, but its default is 10 seconds. So in the world of relational databases, that makes sense. But 10 seconds is still a pretty long time, especially when you consider that in a time series database, InfluxDB might consider a slow query to be something in the milliseconds. So it's important to consider what kind of database you have and also what kind of traffic it has. Because while we do want to monitor how long these requests take, that doesn't necessarily mean that we need to be improving execution time, because monitoring execution time is a separate task than improving execution time. It is important that we distinguish somewhat in the process of monitoring, that we're not always going to be able to optimize everything. Sometimes just being aware of the execution time is enough. Even if you think it's a little slow, it's important to prioritize. So if you are using it for debugging purposes and you find a slow query that, say, in your relational database in MySQL, and it's taking 12 seconds rather than under 10, then maybe the debugging process leads you to improve that query so that it's faster. But if you're instrumenting your application and starting to understand all these different pieces of the database, well, sometimes you don't know how a slow query affects the system until you have more data. So you don't necessarily need to go improving every query that's a little bit slow until you have better information, or really until it causes you a problem. That's my personal sort of a view on optimization, is that if we get into it too early, I spend a lot of time on optimization and not very much on the original task I set out to do. The third metric that I care about here is concurrency. how many jobs is the database doing at once? If you think about it, our applications are largely meant to be used by many people at the same time, which means that a lot of requests come into the database at the same time. So how well does our database handle multitasking? And does that have an effect on the system at large? So in most databases, regardless of whether they're SQL databases or NoSQL databases or time series databases, concurrency is handled by specific algorithms that manage tasks that come in at the same time. I will say that in the world of like academic research, we haven't really determined whether these concurrency algorithms affect performance overall. But that doesn't mean that concurrency isn't important. I don't always need to know about performance. Sometimes I want a different view of my database. So concurrency isn't so much about performance, but it is about helping identify trends. Because like we talked about before, the more context we have, the better picture we can sort of take of what's going on in our database that might be causing problems. So if I know that my database crashes every day at 4:32 p.m., then maybe I also notice that the concurrency algorithm is hitting its maximum number of threads at that point every day, right? Or that the query's execution time goes up every time the number of concurrent requests goes up. These are things that, while we may not be able to improve them, it is important to know about them, because being aware of how your system behaves can affect how we write our code and plan our tooling and inform our users. Lastly, the metric that we care about here is utilization. What percentage of the time was the database available? In the end, this is the metric we care about the most. And throughput and execution time and concurrency, they all kind of combine to create utilization. Because time that your database is too busy to answer a request is time that your users are not getting what they need. So we have to ask ourselves, what are the consequences of your database being unavailable? Does that mean simply a blip that your users don't care about because they're all in the same time zone, and so maybe your database is always unavailable from 2 a.m. to 3 a.m., but it doesn't matter because all your users are on the East Coast in North America? But what we want to know is, say, what percentage of the time was my database unavailable? And then be able to ask ourselves, how did that affect my company, my users, my system as a whole? Because you might have queues building up requests while the database is unavailable that are getting overflowed. You might be getting requests that are lost entirely. There's a lot of planning that goes around having outages. So monitoring utilization is about knowing how well our system performs overall, and not specifically how fast it does it or how long it takes, but specifically about how much of the time was it successful. Because if a page on my blog site, as we talked about, takes a very long time to load because my database is very busy with many requests for many blogs, but it does eventually load, I might have a different reaction than waiting, say, 30 seconds for a page to load that times out at the end, because the results still matter. The good news is that although this can be a lot to think about, most of this stuff is already tracked for you. These metrics are true in almost all the databases in all of the databases I've come across, and I'm sure many that I haven't. And the people who know this job better than you and I have planned for this. So if I'm using Postgres, I can query a database called PG Stats, which already has tabulated the average latency of a request, or how many concurrent threads are being tracked, how many active connections there are to the database. That way, while you can still care about these metrics, you have to worry less about the instrumentation piece. And in the world of deciding which metrics matter, well, the good news is that these databases, they're already tracking all of these metrics for us. They already know that we care about execution time and throughput and concurrency and utilization. So all we have to do is find a easy way to access these metrics. So yeah, we can monitor everything, but we still need a way to easily access it, because while all of these databases are doing the collection, I will say that in my experience, the queries for these databases are not always easy to write. So in the time that it takes me to do some research and write a successful query that gets me exactly like the latency percentile of my MongoDB instance, for example, I can just as easily hook up a visualization tool with a dashboard to just go look at it rather than have to worry about the query. So at this point, you might be asking how Influxdata can help with this. So we do make a database, which is why we care so much about how well they perform and what they're doing. But the really important piece of, say, InfluxDB and the rest of our platform is that we care about developer happiness. So we care about you. And this process of monitoring and instrumentation all the way to dashboarding, we want it to be as easy as possible for you. So if we start with the instrumentation step, your database is already collecting the metrics for you. So you are fully instrumented. Congratulations. Then we go to the observability step, where we just are collecting it. Then we go to this step where we learn from the metrics, which is what I've been talking about. How do we sort of put together this complete picture of what our database is doing, how it spends its resources, and what we can change to be more successful? And then there's a step at the end where we often automate these processes so that we don't have to worry about it. So let's talk about what that looks like. I've talked a lot about the database at Influx. InfluxDB was our first product, and because it was open source and intended to be a tool for the community, it got really good adoption. And once we started to see people really have a use for the database, what we realized is that there was a bigger time series problem to solve, which is essentially that graphic I just showed you. How do we do everything from collecting to analyzing to automating away these problems? So we developed a few other open source tools to help. Telegraph is our collection agent. It's a single binary, all the stack except for our visualization tools written in Go, so they can compile down to a single binary and just get deployed. Telegraph is probably our most widely used tool We don't have a good way to track the numbers, but what we do have is contributors. And we have over 140 plugins written for Telegraph by the community. So that tells us that people are really engaged. And a lot of people use Telegraph and they don't necessarily use other parts of our platform. They use Telegraph because it's so good at its job of collecting metrics and reporting those metrics. It's essentially a very effective data pipeline to get data from one place to another. We also make a tool called Capacitor, which is, for all intents and purposes, our alerting engine. So if you want to get alerted based on an outage in your database, then we can help you make that happen. The minute your database goes down, then you can get that really fun pager alert, right? Or you can set it to a Slack message or an email, whatever it is that makes sense for you. Capacitor can help make that happen. We also have tons of users who write custom defined functions in Capacitor to help analyze the data more thoroughly and apply machine learning algorithms or anomaly detection there. And then on top of all of that, we have Chronograph, which is sort of the user interface for the platform. So you can build dashboards and explore your data and set up alerts from there without having to spend time in the command line if that's not really your thing. I want to show you a little bit about how that looks here. So this is my MySQL dashboard. And the fun thing about this dashboard is that I didn't have to do anything to make this happen. So I have my famous blog site, obviously, running using MySQL as the database. What I did was configure Telegraph, our collection agent, with its MySQL input plugin. So I asked Telegraph to listen for MySQL metrics, and then all of those metrics that we talked about the database creating, it automatically, once I enabled the MySQL plugin, it sent them through, and then I asked them to be sent to this instance of InfluxDB. So straight from MySQL to Telegraph to my InfluxDB instance. And because I'm using Telegraph and Chronograph that you're seeing here in this dashboard, we have some predefined dashboards that we can detect. So when I set up my dashboards, it automatically knew that I had configured MySQL. And it asked me, do you want to go ahead and set up this predefined dashboard? And I said, of course, yes. I don't want to spend my time building dashboards, right? And this is what I got. So you can see that based on what essentially took me 5 minutes to configure, I now can tell my MySQL uptime, which is great news. This is what we talked about as far as, how much of the time is my database available. I can see that it's been successfully running for 1.9 days, which for me is great. For your application, maybe not so much, right? But then you can also see the whole system uptime. You can see the memory. You can even see the system load and the memory usage. And then one layer down, you can see what InnoDB is doing. And InnoDB is the storage database that helps run MySQL. You can see how many open connections there are, max connections, and hopefully what you're getting from this is some validation that the metrics that we've talked about are what matters. These are what is automatically collected and seen as relevant, one, by the people who wrote the database and put them into the performance database of MySQL, and two, by the people who wrote the MySQL Telegraph input plugin and this dashboard. And finding that common ground is what really tells us what matters in a database. So we can see bytes per second, queries per second. We can even see the slow query variable I was telling you about. And the benefit to this is that you get value from the metrics right away. I don't have to figure out what query I want to write or spend time researching which metrics matter, right? What I can do is let those decisions be made for me by the system. And once I do that, I can go to this dashboard as soon as something goes wrong. As soon as I get an alert saying, your blog site is just too good and it crashed and your MySQL instance is dead, I can hop over to this dashboard and see the uptime or see, the number of queries per second that maybe crashed it, or maybe it was the number of open connections, right? There's a lot of information I can gather just from this one dashboard. And if the answer isn't here, I can use these to then establish what kind of queries I do need to write to figure out what happened. Because I already have all of this information to start with. And that information has already been curated, so I don't have to spend my time deciding where to start. So there's a few takeaways that I want to talk about. One is the importance of being aware of how your system as a whole is operating. And we often don't monitor our databases because we trust them so much. Databases are very good at their jobs. Over time, Postgres and MySQL and InfluxDB and Mongo, they're really performant, efficient things. So we often don't give them the same attention as we do the code we write ourselves because we trust them. But that doesn't mean that things can't go wrong or that information can't be of value to us. So I encourage you to pay attention to your database. It's the foundation of your application. And if you're looking for a tool with which to monitor your database, then Influx is a really great place to start. One, because it's open source. You can go download it right now and try it out. We also have a Docker sandbox you can use on our GitHub. You can also become a contributor. So if there's something that you think is missing from Influx, well, that's really the beauty of open source. You can make that happen. And if you're not sure where to start or you have some trouble getting started, you can visit our community site where all our community members ask and answer questions. I'm on there a lot. Several of our engineers are involved. It's where we talk about, what is the newest news in Influx, as well as, what problems can we help you solve? Because I still really care about making sure that open source products are accessible. And I think one way we can do that is by making the barrier to entry a little lower. So visit the community site and talk to us and tell me what kind of metrics you care about in your database. Is there something missing from this list that you would add? I would love to know about it. Again, you can talk to me anytime. If you ever find yourself in San Francisco, we have time series meetups here. We also have them in Chicago, New York, Boston, Austin, Zurich, Barcelona, and hopefully more to come. So with that, I will open it up to questions.
Great. Thank you so much, Katie. We did have a few questions that came in. Our first question is, would this work with a Microsoft SQL Server? If yes, from what version of MS SQL would be supported?
Oh, yeah, super good question. Yes, it will work with SQL Server. And I don't know exactly what version. I don't think it matters. I'm thinking about this a little bit. So the first thing I would check is whether there's a Telegraph plugin so that you could collect metrics from SQL Server with Telegraph. The second thing I would check is We also have client libraries you can use. So if it's easier for you to make a request and send metrics through, say, Java, you can do that. We have dozens of those. And then also you can just make a straight API call to send metrics. So we try to make it as flexible as possible so that you don't have to worry so much about the versions. So I know that it works with SQL Server. I don't know the version, but hopefully with those options, it wouldn't make a difference.
Awesome. Our next question is, how is InfluxDB different from Elastic?
Yeah, excellent question. Elastic is specialized in a different area than InfluxDB. Elastic is really good at full text search. So if you, say, need to search log messages, like log text, Elastic is often a good way to store and search that. But Influx is optimized for time series data specifically. So anywhere that you think you're going to need nanosecond time precision or really high ingest rates, Influx is going to be a better option for you. They both have different roles, and sometimes we see them being used together so that Influx can store the more high precision data and then Elastic can store the text. So they're not really an or situation. I often see them being used together, or you can decide that you care more about text or more about precision.
Great. Our next question is, what is the overhead of these agents if running in production?
Yeah, super good question. That is one of the things that Telegraph does best, is that Telegraph is incredibly lightweight. It has, depending on the tasks or whether it's streaming or batched, that can obviously affect the overhead time. I don't have like an exact sort of measurement to give you on this. I would have to ask our Telegraph engineers, but I do know that Telegraph can run on something smaller than a Raspberry Pi successfully, sending metrics, and that a lot of Influxdata's enterprise users rely on Telegraph in their production environments to get them the metrics they need. So the overhead can depend on, say, batch size or whether you're streaming, but it is never going to stop you from successfully collecting metrics. And I don't think you really see a difference in the overall performance.
Awesome. Our next question is, what tools do you recommend for monitoring databases?
Oh man, I recommend InfluxDB. So I start with what I know and what is free. That's my advice. Whether for you that's Influxdata or not, you decide. But I like to start with tools that are easy to set up and get me sort of to the data I want as fast as possible. And I will say that at Influx we care. We have a phrase that our CTO created called "time to awesome," which essentially means that you should spend as little time as possible configuring and get to what you actually care about sooner. So some of my favorite monitoring tools are Telegraph for collecting agents. If you're, say, a Ruby on Rails developer, maybe New Relic is a thing you already know and is fastest. But that being said, I like smaller modular tools that are free. So I'm probably always going to say try Influx first, but short of that, I would use something that's open source and has good documentation.
Awesome. The next question we have is, what do you use to improve database execution time?
Yeah, that's a super good question. It can depend on a few things. So the execution time, I often look at the cardinality of the data. So maybe it's taking a long time because the cardinality is high and it has to go through, 30 joins to get your results back. What you need to do is look at the request that is taking a long time. And a lot of times that will tell you, what sort of why the execution time is going up. For me, every time I've run into the execution time being high, it's because of a poorly designed schema, usually. So that's something to think about. For instance, in InfluxDB, we have a system where we have tags which are indexed and fields which are not. So when I added too many tags to my Influx schema, I ended up with a huge index. And that affected my execution time because my data was not, it wasn't set up in a way that was like efficient at all. So most of the time, it's either the query itself or the schema. So those are the two things I would start with. If you see high execution time, I would look at, what does this request look like? And if you can't change the query, that might be because of the schema itself.
Great. The next question is, how do you compare this solution with StatsD and Grafana?
Yeah, great question. So StatsD is really effective at collecting metrics, and we have a Telegraph plugin for it. So if StatsD is a tool that you like and are using, then you don't have to take that out. You can simply route those metrics through Telegraph and then into InfluxDB for long-term storage. And Grafana is one of our partners here at Influx. We have really great support. And although I was showing you dashboards that were made in Chronograph, Grafana can obviously do things really similar. And if that's a tool that you prefer, then we're always happy to help you out on the Grafana side. They have excellent InfluxDB support, and in that regard, we try to have really excellent Grafana support.
Wonderful. Looks like we do have one more question, and that question is, does this have a plugin to monitor Docker and VMs as well?
Yeah, we sure do. We are really great at monitoring infrastructure, especially when it comes to containers and virtual machines. You have a few options, right? So you can deploy Telegraph inside of the container and collect metrics like specifically about the application that's running there. Or you can set up Telegraph to sit outside of the container and monitor the actual container. So you have two options. If you have an application running inside of the VM, then you can set up Telegraph to monitor that application. You can also set up Telegraph so that it monitors the actual VM. This is a really popular use case. And in fact, next week, you can see some members of Influxdata at KubeCon North America, where we're going to be talking about something super similar.
Awesome. So Katie, since that was the last question, is there anything you would like to add before I wrap things up?
No, I want to thank everyone for their time and for such amazing questions. I like when I don't know the answer straight off the bat, and I feel like I got to learn some things. And again, I encourage them to download the open source and give us their feedback so that we can improve, and reach out to me on Twitter or through my email if they have any questions.
Awesome. Well, Katie, I would like to thank you for a great presentation today. I would also like to thank today's sponsor, Influxdata, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we will see you next time.